Hey everybody, this is chapter 7, section 2. We're dealing with exponents, and we're looking at how to multiply exponents. Okay, so there's a couple different rules that come with exponents, and it kind of depends on some different ways that the terms are written. And so we're going to need to define a couple of these things for you, so that you can make sure you understand how when things change, what rules you can and can't use. Okay, so if you could kind of write this down for me with your notes. We'll probably repeat some of these things through this chapter, but we just want to make sure that we can keep things clear. Okay, so we're multiplying powers with the same basis. So powers are it's just another word for exponents. Okay, so anytime you see an exponent, you can think of it being a power. It's the powers or exponents are telling me to do something specific, and and that has to do with bases. So bases are the term being raised by powers or exponents. Okay, so you can interchange those two words. Okay, all right. So let's use this first example kind of to look at what the definition is. This is a base. Okay, so it's a 3 right now, but it changes. If you look down here at the next example, the base is an x, so it could be a variable, it could be a number, it could be positive, it could be negative. Down here at the next example, the 2 is a base. Okay, so in this section we're multiplying bases that have the same, or we're multiplying terms that have the same base. Okay, so if you look at these two, they have the same base, so I can put them together. Okay, so let's I'm going to kind of elongate this explanation on this first one to kind of help you understand the rule. So 3 to the 4th really means 3 times 3 times 3 times 3. So I'm multiplying 3 to itself 4 different times. But then I'm multiplying that term to 3 to the 2nd power. Okay, so that, if I elongate that, I'm going to get that. Okay, so then I'm really looking at, well, how many bases or how many terms do I have? Because when I do this, these have powers now, but just now to the power of 1. Okay, so if I count these up, I've got 3 to the 6th power. Okay, so what did I really do there? Well, basically what I did was, if I take this question as it was in the beginning, I really took the base, since it was the same. This rule only applies when the base is the same. I really took the powers and I added them together. Okay, so I get kind of the same answer. All right. So let's do this then. Let's write a rule that we could stand by. So if you guys could kind of make some kind of symbol that to go back and look at this, and we'll kind of write this out. When bases are the same, so I can only do this to bases that are the same. When bases are the same, we want to add the exponents. Okay. Okay. So really important here that we understand how that rule will work. It's only when they are the same that I can put them together. So we'll kind of look at what happens when they're not the same. And we're gonna leave it in this form. Okay, we'll leave it like that. There's times where we might have to actually multiply that out, but 3 to the 6th, I think, gets me like 600 and something. So that's a big number, and we're just really trying to work with a rule right now. This is kind of a rule that you might use in a science class because numbers tend to get big and you represent them more as in exponent form than just some big monster number. Actually, some big smaller number too sometimes, depending on what you're looking at. Okay, so let's take a look at the second one. First thing I'm going to do is I'm going to look at the bases, whatever they might be. So now it's a variable, but the rule still stays the same. Doesn't matter if it's a number or variable, they're a base. So the bases are the same. So what I can do then is go ahead and add the exponents. And you could probably do this in your head. I'm illustrating what the rule is and it's allowing me to do. And so that's then going to get me x to the 9th. Okay. So the bases were the same, allows me to add the exponents. Okay. And I'm just rewriting it as one term. Okay. Once again, if we go down to the second example, we're going to go ahead and look at the bases, and they're all the same. Now, if you don't see an exponent, like in this last term right here, if there's nothing there, there is a 1 right there. We just don't write our numbers with 1 as an exponent, but you're going to understand that it's there, okay? Just like, there's a 1 right here in front of this x that we had in the previous problem. You know it's there, we just don't write it, okay? So this is going to allow me, since they're all the same, to be able to rewrite it kind of, and add the exponent, write it as one term, and then add the exponents. Okay, so we get that. All right. So I wrote out the rule for you, and then what we're doing in our notes, we kind of it's probably a little bit more formal. I think it's almost exactly the same. Okay. If the bases are the same, add the exponents. My definition I gave to you earlier is when the bases are the same, add the exponents. Okay. All right. So I think that's pretty easy. It's just you being able to identify at the very beginning, are the bases the same? And if you have like something else, let's say like I had a 2 to the 5th times x to the 3rd times 2 to the 3rd. Okay, I can put these two together. Okay. And that would get me 2 to the 8th power times x to the 3rd because these two bases are not the same. Okay. All right. Let's move on here. So we're looking at this. I think I'm just going to kind of let you do these on your own. And I think this is a pretty straightforward rule. Are they the same or not? Yes or no. If they are, we get a yes, then we're going to just add the exponents and we're going to leave it like that. We're not going to do anything else with it, okay? So once if you want to hit pause, you can do these two problems on your own, and then I'll do the solutions for you. You can kind of see how you did, okay? So when you get done, hit play and come on back. Okay, so the two bases are the same, so I could write it as one base, and I'm going to add the exponents, and I get 12 to the 7th. Okay. We're going to go ahead and leave, if the base is a negative number, it's a negative number, okay? And let's be really careful with here. We're taking the rules, but we're applying it to different situations. I'm adding the exponents. One of my exponents is negative. I got to kind of make sure I keep it that way. So I should get that, okay? So, rules are rules. Don't try to make stuff up. You know how to add and subtract numbers together. Use the rules and just do the work, okay? Okay, so a little bit different here. So let's talk about this for a second. My base is really 4z and 9z. Now that technically that's the same, especially since I'm multiplying here, okay? So I still want to multiply the 4 and the 9, okay, just like regular old numbers, because you know that's what the operation is, it's multiplication, okay? So I want to multiply those together. I get 36. My base is z, okay? And I'm adding the exponents. And I'll put that negative 12 in parentheses just because I had the plus sign. The plus sign is there because I'm adding the exponents, okay? So when I do multiply these, I'm going to get this. Okay? I get that. Taken by the rule. Now I'm going to expand this just for a second. I can't have negative exponents. So typically, as we move on, we're going to make you have to fix that. You can't have a negative exponent. So what I'm going to do is I'm going to move it, okay? And that negative 7 only is dealing with the z. It's not dealing with the 36 now, okay? So what I'm going to do is I have to turn this into a fraction, and I have to move, remember this is over 1, I have to move the negative exponent to the denominator. So I'm going to move that z to the 7th, and when I move it, it changes it to a positive exponent, okay? But that will come up a little bit more as we kind of go along, okay? All right, so what I'd like you to do is try this one. You got the same base here and here, but you got a different one here because it's got the b in it. So I kind of did one just a little bit ago for you when it was different. So why don't you guys try this one on your own and see what you get. Remember, I kind of do this too with kids. If we're in this kind of situation, in this case, adding them together, if you don't see an exponent, then put a 1 where you don't see, like with either a number or in this case, the variable, go ahead and put a 1 there, just to kind of help you remember that there's 1 there, okay? So if you want to hit pause on this one and try this one, and then I'll do the solution, and then you guys could hit play again and come on back. So sometimes students like to see, grouping things together. Since I'm multiplying all this stuff, I can move things around and not change things. You don't have to do this, but this is sometimes easier for people to see. I'm going to go ahead and multiply the 2 and the 3 together, and that's going to get me 6. I'm going to add the exponents together, so that's a 1 plus a 2. And then I'm multiplying it still by that 9b to the 4th, okay? I'm going to add the exponents. And I get a to the 3rd, but I can't put these other exponents together because a and b are different, okay? Now, one thing math still lets me do, though, I can still multiply the 6 and the 9 together. So that gets me 54, and then I could just kind of stick these a to the 3rd and b to the 4th together, okay? And we deal with stuff like that a little bit more as we kind of move through the chapter, okay? So that's how you do that stuff. Pretty simple rule. If the bases are the same, you could add the exponents, and bases can be a number or a variable. Okay, and it could be positive and it could be negative. Okay, so we're going to apply this to scientific notation. This is more of a science thing, so like a biology or chemistry class, you would use this for. And this hopefully your science teachers teach you this too. So this is just kind of an add-on to what this rule is, how to apply it to a different type of math. Okay, so what I'm going to look at first is I'm going to look at, I could take this 3 and this 2, and I can multiply them together because that's what the operation is. That's going to give me a 6, and then it's times, and since the bases here are 10, now this 10 is based on our numeric system. we have a numeric system that's based on the numbers 10. So I can, since those two bases are the same, I can take the exponents and add them together. So I'm applying the rule that we just learned. So I'm going to get 6 times 10 to the 12th. Okay. Okay, so I'm going to add some notes to this one down below. The one we just did, everything by the rules we have for scientific notation are okay. First off, scientific notation is based on this standard form of scientific notation, okay? In this case, the A is this number out here, whatever it might be. The 10 is the base, so I kind of talked about it a second ago. N stands for whatever the exponent might be, okay? So, but to be able to do this though, when I multiply my stuff out, A has to be greater than 1 and it has to be less than 10. Okay, so there's some stuff we have to do after we multiply it out, like I did in the first example. After we multiply it out, we have to kind of come back to this thing, and we might have to fix it. And really, it's when this is bigger than, when A is bigger than 10, okay, or it equals 10. It can't equal 10 either. Okay, so let's kind of follow the rules, and I'll explain as we go. I'm going to go back and I can multiply the 4 and the 6 because that's what the operation is. So 4 times 6 is 24. The base 10 is the same. And I'm going to add the exponents. Now, you guys, you don't have to rewrite this like I do. I know you can do this in your head, but I just want to illustrate what we're doing. So then I'm going to get this, and I'm going to get a -2, okay? Now, what I have to do is go back here. This is my A, and I have to kind of look at this rule, okay? Is A greater than 1? Yes. Is A smaller than 10? No. Okay, now what I want over here, I'll just show you. Remember, any number can be written like this with a decimal point. We're not going to do that all the time, okay? But if it's bigger than 10, I have to move this decimal point so that this number A is less than 10. So I'm going to, if I moved it to one place to the left, I'm going to get 2.4, and that number is less than 10. Okay, so I'm going to get 2.4 times 10, but these exponents here really are identifying how many decimal places I have in my number. So by me moving it to the left one, I'm going to add 1 to this guy. Okay, so I'm going to get, you got to be careful here because the exponent we got, let's go on. Since I added 1, I'm going to get 10 to the -1. Okay. So a little bit of rule there. You got to make sure, let's write that down. And I write the standard form down too, so we kind of know what we're talking about. Okay. All right. I think that was it. So just make sure it's a really simple rule that we began with. The scientific notations is kind of added in there because it follows the rule that we talked about. And scientific notation is not a big deal to get worried about. We're going to practice it a little bit more. So just do a good job on it. If you got any questions, please ask. Okay. Thanks. Bye.